Welcome back, everyone. Moving on to another example dealing with infinite limits. So we got to find the limit as x approaches -3 of this function here, 2x minus 3 over x plus 3 squared. Notice that this function, very similar to the previous video, except now instead of just x plus 3, we have a squared here. So it's a bit more complex because it's not linear over linear anymore. It's a linear over a quadratic function. So they're asking us to find the general limit. Notice this is not a one-sided limit, dealing with approaching that -3 from the negative side or the positive side. So we actually have to approach it from both sides, right? So we're going to have to approach this -3 from the left side, or from the negative side. So -3.1, -3.01, -3.001, and then we're also going to have to approach it from the right side. So -2.9, -2.99, -2.999. Right? So if we draw what's going on here, I'm not going to draw the whole function yet, but we know that there's going to be a vertical asymptote at -3 because that x value makes the denominator 0. And notice there's no factors that cancel out, so it's definitely not going to be a whole, so it's going to be a vertical asymptote. And so we're approaching that vertical asymptote from the negative side and from the positive side. So all we have to do is take these x values and plug them into this function to get the respective y values. And when you do that in your calculator, you'd get these respective y values over here. So notice as we approach -3 from that negative side, from the left side, notice that the y values are going towards positive, or rather negative infinity. So they are going this way. And then as we approach -3 from that positive side, or from the right side, the y values are also going towards negative infinity, this way. And so that means that this limit here, this general limit, is equal to negative infinity, because from both sides, that's what it is approaching. Remember in the previous video when it was just 2x minus 3 over x plus 3, this limit didn't exist. The one-sided limits existed, but one went towards positive infinity, the other went towards negative infinity. So that overall limit didn't exist, but with this squared here, it makes the y values from both sides go towards negative infinity. And so that general limit here is going to be negative infinity. And this graph is a little bit more complex to sketch, but if you were to do it, basically what happens is there's going to be a y-intercept at -1 over 3. If you plug in 0 for x, you'll get -3 over positive 9, which reduces to -1 over 3. And then there's also going to be an x-intercept at 3 over 2. So let's say like right here. And so this kind of looks like, and it's going to come back down. And then this here looks like that. So there's going to be a horizontal asymptote at 0 because you have a lower degree over a higher degree. So over here it's smooth. Over here it's actually going to cross that horizontal asymptote of 0 at 3 over 2, and then it's going to come back down. So just a review of advanced functions and those rational function type of graphs. But anyway, if they're just asking for the limit, you don't necessarily have to graph it. All you need to do is make these two tables and see what value is the y coordinates approaching from both sides to where you're approaching that specific x value that you are asked for.